Hello, this is Yannis from Any Repair. Today we will go through a gaming notebook repair for an MSI GE75 RAIDER gaming laptop that came to us with a nasty burn on it. We talked with its owner and we have decided to give it a try. Let's go and see how we'll deal with this damage. This is the board, this is the microscope view, this is what we saw initially, and the view was very disturbing. There is a lot of damage on the board. You can see the layer, the copper layer that is on the upper side. It is in the air. You can see it is delaminated. Some of it is welded. We are trying to cut this layer that it is in the air and connects to nowhere or somewhere that we don't want to be connected, because an unstable layer will cause more problems. You can see the capacitor is in the air too. This is a very big damage. I think all the layers are welded, are touching each other, so the short is big. We didn't believe that we can do something about that, and we were not very eager to start the job. That is the way that I will try now to take some measurements with my multimeter in continuity mode, and it will not be displayed on the video because I didn't even bother to connect the multimeter to be shown on the video, because it was very disappointing for me and I didn't believe that we can do something about that. We have tried with our multimeter to check what is ground and what is not, but everything was ground, so we should grind everything around to check for some improvements. Unfortunately, it is not on camera. You will see the results of our digging, which are these. The board is turned the other way. You see the capacitors. We are trying to clean our way in order to have a clearer view. This is the damage. You can see that there is a hole on the board which is connected, connecting a MOSFET, an upper MOSFET of a buck converter that is feeding the VRAMs of the GPU. You will see it in a minute. So this was the real damage. We have removed the layers that were grounded, and this is the MOSFET that we have removed. You can see the hole. It's a big hole. You can see the hole on the 19 volts on the vein, which is huge. This is the MOSFET that was burned. The damage that was visual on the MOSFET was very little, but beneath it was huge, as you can see. So that is the hole. The hole was in the size of a screw hole. And what we have achieved is to remove the short. I don't think that this board will work with its GPU, because the VRAM were shorted and maybe killed. And I don't know if our customer wants to be replaced, the GPU and maybe the VRAMs. Now we'll check for short in the 19-volt rail in the vein. This is the DC-in section of the board. I am connecting the multimeter, and I will now check for short. The first MOSFET is connected with these 4 filters that are feeding the first MOSFET. This is the current sensing resistor. You can see that it is having a very good resistance to ground, so there is no short. And I think we're good to go. We can mask the area around and check what we have done. A part of the masking will be shown on camera. We are masking because maybe a fragment of copper can go on the layers and cause damage, and maybe bigger than the initial one. So we're masking almost everything in order to keep the layers isolated from each other, which is the purpose of this digging. We are applying a thin layer of UV mask with our tool, and we will cure this UV mask with UV light with our UV lamp. Likewise, and after a few seconds, the mask will be cured and we will be good to go. We were masking initially the layers that are very close to each other after we have dig so much. The UV mask is cured. Now we must make our tests. Our tests we will go very quickly. We will check for ground again if something disturbed the vein, but it's okay. You can see, you can see, but if I press better, harder, you can see that the ohms in the vein is very good. And here's the hole, which I have named Hall of Fame. This is the board. We must plug it on its chassis in order to check if we have good amps and if the processor still has the ability to produce the display, because I don't think that GPU will work without the feeding of the VRAM. So we will plug its heatsink. We don't want to stress our gaming notebooks without a heatsink. We will plug the power, and we will see that we haven't connected the EDP cable, so we must remove the heatsink and plug the EDP cable in order to have a display or to see something. So that's what we're doing now. And now it's the time for the power button to be pressed. Okay, it is drawing, it's consuming some amps. Good amps. We will wait. Patience can be a good thing. It is RAM training, I think, now. Yes, it is RAM training. So maybe now we will have display. Maybe not. And that is the symbol we want to see, the BIOS plus screen. We are good. Sorry again for not showing the grinding section of this repair, but we didn't believe that we can achieve such a repair, so we didn't even bother to record the process. But I wanted to share it with you because this notebook works with its GPU not recognized, as you can see. So, we are good. That was the repair as you saw. If you like this video, consider a like, subscribe and share. Thanks for watching. See you in another repair. Bye.